Okay, so last day for dynamics. And we will be spending a few days on this just to make sure we understand this concept. So we have the problem forces on an inclined plane. So an object on an inclined plane. So like any force question, we need to be able to draw the free body diagram, the forces acting on the object. So we have this block acting on sliding down this ramp. Okay, have other scenarios where object is being pulled up a ramp, being pushed, slid around, pushed in different directions, whatever. But simplest case, object sitting on the ramp, probably going to slide down if it overcomes friction. Stay where it is if it doesn't. Let's see what direction our forces are acting on it. So when we draw a free body diagram, usually draw at the middle of the object. For neatness purposes, I like drawing it just right here. It's a bit easier to see. So force of gravity acting downwards. Nice and big, I drew that one. Normal force is always perpendicular to the surface. So it's not straight up. Normal force is actually pointing in this direction. It's perpendicular to the surface. Okay, so that's our normal force. So you have force of gravity, and we have normal force. Friction always opposes the direction of motion. So if we just have this block sitting on it, the block wants to go downwards. So our friction force is opposing our direction of motion, force of friction. So those are our three forces acting on this object. I'm going to show you a little bit more though. Force of gravity. I'm going to draw a little triangle like so. So the FG is the hypotenuse of this triangle because of the triangle itself. But I'm going to draw my components like so. I'm going to call this my Fx and Fy. So the interesting thing about inclines is actually easier. Instead of thinking of our axes as up and right, like our traditional X and Y axes, we're actually going to reorient our mind. So we're going to orient our mind like the following. This is our axis. This is going to be our x-axis. This will be our y-axis. The reason we do this is because if we do our traditional one, what we can see is that, okay, force of gravity is only has a y component, or force of friction has both an x and a y component. Same as normal force has both an x and a y component. By rotating our mind, rotating our axes, we're actually simplifying it down because now we can see that Fn is along the y direction. Force of friction is along the x direction. Also, we know our acceleration is going to be going in that direction as well. So if we used our traditional x-y axis, acceleration would have both an x and a y component. But by rotating our axes, acceleration is now clearly seen to be in just the x direction. So to move ahead with this, we have to say, okay, because this angle theta is right here, this is a 90-degree angle here. So let me just put a number with it. Let's say if this was 30 degrees, we know this would be 60 degrees, and therefore this would also be 30 degrees. So all I know is this is theta. So whatever angle there, whatever the angle is here in the ramp, it's also the angle in this triangle that I drew. So 30 degrees, 30 degrees. What we can see from this as well is if I redraw that force of gravity vector with its x and y components, Fg, we can think of it as this is like our applied force. And if we look in the y direction, there's normal force going upwards. So normal force, we know it's not accelerating along that y direction, that slanted y direction. So that means that Fn must equal to this Fy component of gravity. If there's no friction, like if an object just falls, it falls at a rate of 9.8 meters per second squared. However, if something's on a ramp, it's going to accelerate at something less than 9.81 meters per second squared. So meaning how big of the incline, the faster it's going to fall. The less steep of an incline, the slower the rate of acceleration. So just to reiterate what we're saying, if we scroll down here, if we use our traditional x and y axes, we get quite a complicated expression. Whereas if we rotate our axes, rotate our mind, we can simplify the equation significantly because we reduce the amount of angles required in our expression.